All right, everybody, welcome to another OpenShift Commons briefings. Today we have Rob Richardson from MSQL, who's going to talk to us, give us an overview of databases in the microservices world. I'm going to let Rob introduce himself. We'll have live Q&A in the end. We're streaming on Twitch and Facebook and YouTube, as well as in Blue Jeans. So if you're joining us from any of those places, we'll aggregate those questions and relay them to the speaker. And then we'll post the video with links to the slides into the YouTube channel for Red Hat OpenShift under an OpenShift Commons briefing. So don't take tons of notes. We'll make this happen for you, and just pay attention because there's a lot of great information coming. So please, Rob, with that, take it away and introduce yourself.
Marvelous, thank you. I'm really excited to get to present here to all of you from around the world and across the globe. This is a really fun chance for us to dig into databases. Here's the part where I tell you, I am definitely going to post the slides on my site tonight. You're going to go check on my site tonight, tomorrow, next week, next month. In about 3 months, you're going to get tired of pushing refresh and you'll email me. And I'll promptly reply in 6 months and say, I'm definitely going to post them on my site tonight. And I'll never post them at all. I've run into this scenario enough that I take the complete opposite approach. My slides are on my website right now. You can go to robrich.org and you can see these slides on my site right now. Let's go to robrich.org and click on presentations right here at the top. And here's databases in the microservices world. You can get to the slides that we're about to look at right now. While you're here on my site, click on About Me and you'll get to this page. And this is some of the things that I've done. I'm a Microsoft MVP. I'm a friend of Redgate. I'm an evangelist for MemSQL. AZ GiveCamp is wonderful. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp in your area, reach out to me on Twitter or by email, and let's get philanthropy installed in your area too. Some of the other things I've done, SQL Source Control Basics, mine is Chapter 8. That was a lot of fun to write. I worked on Gulp in version 2 and version 3 as a core contributor. And one of the things that is particularly cool is .NET Rocks. I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, is I have a coveted .NET Rocks mug. So let's dig into databases in the microservices world. Talk about this guy. Application architecture. Let's start here because this is kind of fun as we look at the mechanism of microservices. When we look at microservices, we can kind of think of it in this way. We started with spaghetti, we moved to lasagna, n-tier architecture, and ultimately we ended up with ravioli microservices. I really enjoy this analogy, and here's as you grab the slides from robrich.org, you can click through on this purple link to get to the article that describes this spaghetti and lasagna and ravioli mechanism. It's a really, really cool analogy. Looking at it differently, we used to have monoliths here on the left. And in that monolith, we had all of the pieces of our application. In this case, we separated it into an n-tier application. But ultimately, it's all deployed in one piece. And we deployed it in one piece because deployment was hard. We'd get on a conference call at, 2 in the morning on Friday night, and we'd keep deploying until Sunday afternoon when we got it right. And it was hard. It was really hard. Because it was hard, we didn't do it very often. Well, fast forward to today, and now we have containers that makes deployment really easy. It's cake to spin up a new system to get content forwarded from the internet. Deployment is no longer hard. Because deployment is no longer hard, we can architect differently. we can architect as microservices here on the right. And so these microservices, each one is responsible for a very small piece of the application's functionality. That makes the code a lot simpler. It makes the program really elegant, and it makes it replaceable. If we have a change in business logic or in business need, we can swap out a microservice with a different microservice that accomplishes the task better, or add new microservices to accomplish new tasks. And each of these microservices then can scale independently. So we don't need to have one big box or many big boxes to accomplish our website. We can have lots of little pieces horizontally scaled to accomplish the needs of our content. Now here in this, we have a user interface, and the user interface will probably hit a load balancer that will then proxy off to each of the microservices, or we may have microservices running on subdomains. But then the microservices, as they need to reach out for data, they will reach out to other microservices to get the content from that microservices data. So as we look at microservices, they do one job. They're easy to deploy now with containers, and they can scale independently of other content. If we need to scale up the shopping cart, we don't also need to scale up the login system and the monthly reporting system. They're easy to replace. And in particular, one of the tenets of microservices is that each microservice should own its own data. Now, the beauty of having the microservice own its own data is that if that data needs to evolve, if that microservice needs to get replaced or adjusted, then there's no concept of, well, who owns this piece of data and can I change it? And do I need to get all of the approval processes? That microservice owns that data. And as the microservice evolves, the data can evolve too. Well, we set out to build microservices, and we want them to own their own data, but usually we fall back into a pattern like this, where we have one monolithic database. That database that we used last year, or 10 years ago, or a generation ago. And we have our microservices, but they all talk to the same database. Bummer. Well, why do we do this? Well, there's a lot of reasons, but provisioning the database is still hard. There's a lot of content in there, and when we lose a database, then that's traumatic to the organization. We've just lost data. We've lost customer records. If we lose a web server, yeah, we can prop up a web server. The website may be down for a little bit. Said another way, what'll make the news is losing the database. It won't make the news when you lose a web server. So databases are hard. Ultimately, the DBA's job is to make that database secure and accessible. And so ultimately, the DBA is likely going to say no when we say, hey, can I have another one? Yeah, DBA's job is to enforce safety within a data structure. So it kind of makes sense. You know, I'd hope that we could get a DBA to focus less on guarding and more on facilitating in a safe way. But that's another conversation. So ultimately, the DBA is pushing back. He doesn't want too many little databases because did we remember to secure it? Are they all backed up? It's really easy when we have lots of little databases to forget that basic database hygiene. I guess we didn't back up that database and completely lost all of our customer data. That's not something that we want to hear. So to avoid that, we don't create these little databases. We have one monolithic database. So now what do we do about it? Well, if we must use a monolithic database, we can treat it like lots of little databases with bounded contexts. And a bounded context is a methodology within an application to be able to carve out that portion of the database that is necessary for this particular task of work. When we think about a bounded context, we could look at a shopping cart. Well, a shopping cart needs access to the product catalog. The shopping cart experience probably owns the product catalog portion of the database. all of the product descriptions and all of the pictures, but they don't need to own the customer record. They don't need to own HR data. They only need to own the product catalog and the shopping cart, the orders produced. By comparison, the fulfillment system doesn't need to worry about what is the product description and the pictures at all. The fulfillment system's goal is to ensure that the content is delivered, ensure that it's shipped. So they own things like the shipping address and the order status, updating the order status to mark that it is shipped. They may own some billing details, was it billed, or perhaps that's a separate system, the billing system, that owns credit card information and an order's payment status. A bounded context allows us to carve up our monolithic database into lots of little pieces. And now we can treat those little pieces as if they were, let's coin the term, microdatabases. Now in time, hopefully we can get to the concept of microdatabases, lots of little databases, where each hopefully we can get to microdatabases where each microservice owns its own database. But in the shortest term, a bounded context is a great way to go. How do we get then to microdatabases? Well, here's that microdatabase mechanism where each microservice owns its own data. Now we still have those two concerns about who owns the backup and who owns the authentication story. So to get to microdatabases, we need to do interesting things like a mechanism to enroll a database in an authentication and backup strategy. We need that automation. When we have that automation, we can move to microdatabases. We can get to that point where we have lots of little databases that accomplish lots of tasks. A microdatabase, it's owned by one microservice, and other microservices that need to get data in this database will call that microservice to get or change data within this database. So how do we do joins in a microdatabase? Well, this database may publish events to a service bus. Now, a service bus is really interesting. A service bus, like Kafka or a similar type of thing, is a mechanism for communicating between disconnected systems. The beauty of a service bus is that the publishers can publish content into that service bus, and they don't need to get that data consumed right away. Simultaneously, a consumer can grab data out of that database whenever they're ready, and might even be able to back up and reread some of the data out of that service bus. So if we have a service bus between our microservices, then those things that need to can publish events into the service bus, and those things that need other data can subscribe to that event in the service bus. We call this event sourcing, where we'll publish events into an event store, and then we'll consume those from another store. So how do we do joins? Well, we listen to the events published by that other microservice, and we keep track of the content that we care about. At that point, when we're ready to join, we own all of the data that we need to join on. So here's another good example. So who owns the customer record? Well, if we're in microdatabases where each microservice owns its own data, well, do all of them own the customer record, or do we go back to a monolithic database where the customer record is, one big piece? So, for example, should the shopping cart own the customer record? They're responsible for creating an order based on a customer. They'll likely verify the shipping address. Or should billing own it? They're the ones that need to own the credit card information. Or should human resources? Human resources has lots of, secret data about the user, and it needs to be kept within HR's boundaries. Or should sales own it? They're probably the first person that saw the customer. But in sales, there's very different validation requirements. For example, a lead or a prospect, they may only have a name and a phone number. They may not have a company address. But for order entry, we need to have a full shipping address. We probably need a phone number. So if sales is responsible for the customer record, do we enforce sales to enter in all of the data before we begin? Well, now they're starting to use, I don't know, Notepad or Excel to keep track of their leads, and duplicate databases is always fun. So who owns the customer record? Well, we probably want to create a new microservice that is the customer record. And that customer record would only be the primary key and the account number, maybe the company name. But after that, all of the rest of this data is specific to each microservice that needs it. So the shopping cart can call into the customer microservice and say, hey, I've got this customer ID. Is this a valid customer ID? Or I've got this account number. Is this a real account number? The billing can go ask the customer microservice, hey, I've got this credit card detail. Is this customer still active? Can I still create this purchase for them? Human resources has all of their data within their human resources microservice, but the customer ID is still in the customer microservice. Because we have this mechanism where each microservice owns its own data, then each one can define what customer means to them. To the customer microservice, a customer is merely an auto-incrementing primary key and an account number. Everything else is stored somewhere else. Sales has their microservice that has a foreign key off to this customer microservice, and they have all of the lead and prospect information. Shopping cart has all of their shopping information, all of the order history, and billing has all the credit card details. We've created a schema where we have microservices that have maybe overlapping bounded contexts, but each of them still owns their own data with no overlap into any other data. Using event sourcing, we can get different data to different microservices, or if the billing service does need to call out to the customer microservice, then that's totally fine. So MicroDatabases, we've reached it. We've gotten to the point where each microservice owns its own data. We have enough automation to be able to enroll these databases in authentication and backup strategies as soon as they're created. So we know we still have that data safety, but we also have a user experience, an architected system that will scale horizontally rather than needing to scale vertically with very large database servers. We've gotten to, let's coin the term again, MicroDatabases. This is really cool. Microservices require MicroDatabases. If we have the automation to get there, then it can be really, really cool. Well, the other thing that's really interesting here now is when we have MicroDatabases, each database doesn't need to be the same kind of database anymore. That's pretty cool. So some microservices may be able to store data in a form that is better suited to that database. So let's take a look at that. I love this quote. They don't all have to be the same database vendor or the same database type. Said by me right now. Okay, so because they don't all have to be the same type, let's look at some of the database types that we now are able to choose from. Well, relational, a SQL database, a document database or a NoSQL database, a graph database, key value, time series, search, object or blob store, file store, column store. And let me introduce you to NewSQL databases as well. So first up, with each of these, we'll look at the characteristics, the pros and cons, best use cases for this particular database type, and some example databases that will get you to Google search terms. I'm definitely not pitching a particular database in this section, but when we look at examples, that will help you to be able to Google it. Okay, first up, relational databases. what I love about relational databases is it's a great default. It's a really easy mechanism to understand. In a relational database, we have rows and columns. You can think of this like an Excel spreadsheet. With a spreadsheet, we have rows and columns. One of the big defining characteristics then of this is that each column has exactly the same kind of data in it. I'll have a state column, and in each state, in that column, I'll list each state or province. I'll have a phone number column, and I expect that to only have phone numbers. I'll have a created date column, and I'll expect all of the values in that column to be dates. One of the things that makes it a relational database is the SQL engine. And this SQL engine uses English-ish like queries, and so we can kind of get those SQL queries. This SQL engine has been tuned for generations to be really compatible and really efficient. So as we look at relational databases, we know that they're going to be pretty fast and pretty easy to use because they have this consistent SQL experience. One of the things that's particularly cool about relational databases is ACID compliance. Let's take a look at ACID compliance. Atomic, consistent, isolated, and durable. Now, I love this, this talk here where they talk about all of the particulars about ACID compliance. And I'd invite you, as you grab the slides from roberts.org, to click through this link and read this article. ACID compliance suggests that all of the data either succeeds or fails together. We're not going to get part of the update through and part of it not. We're not going to lose some of the data. All of it either gets through or all of it doesn't. By comparison, we have eventual consistency. In eventual consistency, we'll push it out, and in time, it will get to be okay. But if we save and then quickly read, we may get the old data. An example of an eventually consistent system is ordering something at Starbucks. You go to Starbucks, you place your order, they hand you a ticket, a tag, or they ask for your name. Once they've finished preparing the thing, they'll come back and they'll give you your order. A similar thing is like a bank statement. If I go to my bank right now, I may or may not have the charge that I just made at Starbucks. But at the end of the month, I'll have all of the details of my statement there. Is eventual consistency sufficient, or do I need ACID compliance? That's definitely a question for your organization and probably for your microservice. Does this microservice need eventual consistency or ACID compliance? So here's those details of a SQL database: rows and columns, one big server, tables of consistent rows and columns, ACID compliance, and SQL queries. One big server. So typically, because database engines were built before multi-threaded CPUs were a thing, most SQL database engines scale vertically. I can't really put two machines together and tell them you're one database. That's kind of a bummer, because to scale up, I just have to keep buying bigger and bigger boxes. Eventually, I may get to the point where I run out of box, or I run out of money to buy that box. Relational databases usually being one big server, that could be a pretty big bottleneck. So next up, so here's relational databases. Their strengths are in a strong schema. I can do table joins. I have that very fast optimized engine. I have that compatible familiar syntax. On the downside, I must scale up that one big box. And ultimately, I probably will normalize my data to third normal form to be able to reduce redundancy in my data and ultimately to reduce database storage. To that end, I may choose to use an ORM to be able to get at this data easier, an object relational mapper that does that heavy lifting of turning my objects in my application into rows and columns in my database and back. It'll take my code-based queries and turn them into SQL queries and return those results. So we've got relational databases. Ultimately, the best use case for a relational database is probably a good default choice. If you're in a monolithic database scenario, your database is probably a relational database. Here's some examples of relational databases that'll get you past that Google search. Next up, let's look at NoSQL databases, or document databases. I'm going to call them document databases because pretty much anything that isn't a relational database is technically a NoSQL database because it's not using that relational SQL. But in particular, when we say NoSQL, probably what we mean is a document database. Now, the beauty of a document database is that I can take this JSON blob and I can stick it in my database as one piece of data. Instead of tables, we'll probably talk about collections, and we probably mean the same thing. The interesting thing about these JSON documents, though, is that they don't all have to be the same. Each document can include or exclude any fields that they need to, and I can nest content within this record. They're ultimately optimized for reads, and so I may choose a schema that is, well, a little bit redundant to ensure that I can read really quickly. A great example might be a news site where I need to read everything about that news article in one shot. So I'll put the author name, I'll put the author's details, I'll put the title and body content, and I may put the first 2 comments in this single document so that I read by ID, I get back that entire document, and I render that page in one go. Now, most document databases are distributed across many machines. That means I can use commodity hardware there, and so I don't need to scale up to one big object or one big machine. That is wonderful. But because of that, they'll set aside ACID compliance for eventual consistency. Is it committed when I only write it to one machine, or is it committed when I've distributed that to all of the machines? Do I need to wait for quorum across all of the cluster to be able to decide that that data is committed? Different NoSQL databases here will make different choices there, but ultimately that's kind of the major difference here. SQL databases are one big box, and NoSQL databases are JSON documents on many boxes. So when I'm looking at a document database, it is distributed. I have no schema, which means that I don't need to care for it. I don't need to migrate it. On the downside, I have no schema, which means my application probably needs to enforce different things. Like my database probably does have a schema in the mind of the architect who built it, but now I'm just not telling the database about it. So now I have to do things like, well, what if I read data that doesn't exist? What if I'm trying to do a where query, a filter, on a field that doesn't exist? So no schema can kind of be a two-edged sword there. Ultimately, because I'm outside of SQL, we may kind of try to layer a SQL-like language on top of a document database, but I'm outside SQL. I don't have that really, really fast-tuned engine. So we end up with SDKs for each language, and that SDK may have, JSON-like query syntax, but it's not SQL. Or maybe it is SQL, but now how do I talk about nested things? That can get a little bit weird in document database. One of the big downsides to document databases is each collection is its own island. There isn't really a concept of joins in a document database. Now, maybe that's okay, but the way we avoid joins is we denormalize our data. We have duplicate copies. That does make writes more expensive because I need to update all of the copies. But again, in document databases, we're optimizing for reads. So here's some examples of document databases. Document databases might be a great use case for a product catalog, a news site, a CMS, something where I need to get the entirety of the thing really quickly. And the fact that I'm storing it in a little bit of a weird scenario, or I don't have ACID compliance straight away, is okay. So next up, let's look at graph databases. Graph databases are really cool in that they focus not only on the things, but on the relationship between the things. Here's an example query into a graph database that focuses on the relations between people and the company they work for. Now I can do things like friends and friends of friends really easily in graph databases. And not only that relationship, but I can hang data off that relationship as well. Relationships then are directional, which is pretty cool. So a graph database How's that different from a SQL table with 2 foreign keys? Well, yeah, I could kind of start to fake a graph database with SQL, but it's that query syntax that makes it really elegant. The concept of being able to join across those relationships in a really elegant way. And so to that end, graph databases are really tuned for those relationships. So on the upside, it's really fast to be able to query into those relationships, to keep track of those relationships. On the downside, it's made that choice at the expense of other things. Now, it may do those other things okay, but its focus is on the relationship. So if you need ACID compliance, or you need really tight SQL, or you need joins, then a graph database may not be able to perform as well as a SQL database in that context. So a graph database, here's some examples. Graph databases are great for social networks because social networks really focus on those relationships. Messaging apps where I need to keep track of all the messages between people. Maybe a recommendation engine might work for a graph database because it's keeping track of relationships between products. Next up, KeyValue Databases. Now, KeyValue Database is really cool in that given a key, go read a blob of data. Often the data is JSON or a big text blob, although ultimately what's interesting about KeyValue Databases is the value is anything. We could think of this as a SQL table with a primary key and a binary blob value, those 2 columns. So whatever I choose to write in that binary blob is kind of irrelevant to the KeyValue database. I just write it based on that key, and when I want it back, I go ask for that key and get that value back. This is really great for those key value type of experiences, those by ID type of experiences. These can be great for caching servers if we need it. I can store different data in each of the values because to the database, it's just a binary blob. On the downside, I can't really query for anything but ID. If I need to do a where clause on content within the value, for the most part, I have to read all the keys, deserialize that data in whatever way makes sense for what data I wrote there, and then look at that data and see if it matches. Not really an efficient mechanism. If we need that kind of query into the related data, we probably want to lean on a different type of database. But for those cases where I really need to search by ID and I need to match on that ID really quickly and just get that data straight back out, KeyValue Database can be perfect. So KeyValue Databases, here's some examples of some KeyValue Databases. They're best used for caching, for configuration, user session data, anything that is that big binary blob of stuff that I just need to access based on a key. Next up, time series databases. Isn't it cool that we have these MicroDatabases so that we can explore all of the different types? Here in a time series database, we're looking at different portions of time. We'll create time windows, time buckets. Now, what's interesting, if I think of an Excel spreadsheet, I assume that there's only one piece of data in each cell in that spreadsheet. Well, in a time series database, I can create a window that is a week or a month or a day or an hour. And in that cell, I have all of the data that matches. What's then cool is I can query into that window to get interesting things like min and max and average and count. And that can be some really cool analytics to be able to create those windows, understand the quantity of content within those windows, and to start to search for trends within those time windows. Time series databases are great when I have very time-specific data. Perhaps I have sensor data coming from a mobile network or another type of time series data where I have lots of events that need to jump into my data store. It's not great when I have more generic data because, well, since we've set aside that SQL engine, it's really tuned for this time series thing, not for all the other things. Here's some examples of time series databases. And it's really great for that IoT monitoring or real-time events. I might choose to grab real-time events from mobile devices or sensors, maybe stock trades or click streams. Those are great for time series databases where I need to know, did that event happen within that time window? What was the min and max or the quantity of events within that time window? When I need to handle that data in bulk in that way, time series can be great. A text search database. We can think of this like Google or an elk stack. A text search database's focus is on finding matches within a document. Given a text document, we'll go pre-catalog all of the pieces, we'll identify all of the words. We'll be able to then reach into this with an inverted index to be able to identify matches within that document. I'll type a query, it will go find a match, and it will show me which documents or where in that document is the match for my query term. Now in time, we may pair this with a natural language processing engine so that I can ask it questions more so than just search for terms. And that's a really good line extension for this. The text search database itself isn't that natural language processing engine, but pairing those two is a really elegant solution. Text search databases are great when I'm trying to do that, find the documents that contain this thing, or find the spots within this document that need this thing. Not great for joining on things. It's not great for relationships between things because it's really focused on that finding the content within the document. One of the things that's a major barrier here is stop words. In English, the words a, and, on, those words that don't really have meaning on their own. So I may choose to eliminate all of these stop words from my index so that my index is significantly smaller. Now, this is very language and culture specific. So if I have an English set of stop words and I'm storing data in other languages, then those stop words don't really make sense. Or maybe a word in English is a stop word, but not in another language. A great example is I may choose to not index A because A by itself has no meaning. But what about when I talk about the street Avenue A? Well, now the A is really important. Did I create a stop word that was A that just completely dropped it? And now all that I've indexed in the street name is Avenue? Did I shorten Avenue to Av and add that as a stop word because, Av usually doesn't have anything? At that point, this record has, well, nothing to match on. Stop words are really fragile within a text search database. So text search databases are great when I need to go find the content within a document. Here's some examples of them. It's great for matching documents or matching content within a document. One thing that's interesting about Splunk is that Splunk will actually put in the schema later. So I can just quickly ingest all the data and then I can analyze it later and put in a schema so that I can start to wear on different columns or content. Next up, an object store or a blob store, or we could think of this as, a file system. I'm not going to say file system because, that has a very specific connotation. S3 isn't a file system, or is it? The key is a path into that document, and the value is, well, whatever I choose to put there. It's really great to think of it as a file system. At that point, I may not have folders per se, but I do have documents and I may choose to create a naming convention that nests them in these simulated folders. That's pretty cool. These object blob stores are great for very large things, for videos, for file backups, system backups. They're not great for when I need to query inside those big things. If I want to do a where on an object store, I basically need to open up each document, deserialize it in whatever way makes sense for that, and then search that document using a different mechanism. So maybe I open up each backup and now I need to unzip it into place and then, or maybe I open up each media file and I go looking for images within each frame. Or not, you can see that wheres in object stores are pretty fragile. So object stores are great when we need to store big things. We probably don't want to put a database backup or a video file in a cell in a relational table. Suddenly our database is, 2 or 3, 5 times the size. But we do want to upload this to maybe our NFS file share or to another blob store where we can keep that object as an object, just as a binary blob, in a lot cheaper mechanism for storage. Here's some examples of object stores. Next up, column stores. Now, column stores are a really innovative adaptation to SQL databases, where instead of storing the data in rows, the data is stored in columns. So in a traditional system here on the left, I would have all my rows, and each row would have the entirety of the data associated with that piece of that row. In a column store, I'm going to create a different type of index. I'm going to create all of that data in columns. Now, using an example of countries in the world, or maybe states within the country, there's very few, and so I can get a really good compression on this. If I'm looking for all of the states within the country, there's maybe a dozen or a few dozen, and I can make a couple of entries in this thing, and it becomes a really well compressed index. Now that's really cool for doing analytics because I can reach into that column store and I can pull out the values that I need. I can quickly get to that section and grab all of those values. Column stores are great for faster seeks and for bulk reads. By comparison, row stores are usually better if I'm doing transactional data, where I need to do lots of random reads and writes, because lots of random reads and writes aren't really the job of column stores. Here's some examples of some column stores. Ultimately, column stores are great for analytics. If I need to do analytics on data, bulk reading and bulk analysis, column store can be a really good way to store that data efficiently and query it quickly. So next up, let's talk about new SQL databases. A new SQL database is a new type of database that focuses not just on SQL and ACID compliance and all of those pieces, but also adds with it distributed. One of the big barriers of SQL databases was they were architected when one machine, one thread was the name of the game. So with a new SQL database, we may choose to, in this case, we're looking at a MemSQL architecture, we have a few aggregator nodes. We'll submit our queries to one of these aggregator nodes, and it will go reach into leaf nodes to get the data out of the partitions. So the data is partitioned into lots of different commodity hardware. And so now to add more capacity to our database, we just add more leaf nodes and more aggregator nodes. At that point, now we can get much more performance from a larger database without having to buy yet another big box. We can think of this as SQL with an SLA. If ever you have the spinning wheel where you're waiting for that query to respond, a new SQL database is probably the right choice. New SQL databases, they are much cheaper to scale. On the downside, because my data is stored in partitions, to do something like a join may require data moving across the network. Now, normally all of these nodes are going to be close to each other so that network latency isn't a major bottleneck, but that's one thing to think of when we're looking at a new SQL database. So new SQL databases, here's some examples. New SQL databases are great when I've outgrown my SQL database, when I just can't buy a bigger box, or when I need to store more data, or when I get that spinning wheel of doom where my queries are just taking too long. I can get to that spot where I can partition my data across databases, partition my data across nodes, and be able to get at that content in a very multi-threaded mechanism. So one of the things that's particularly cool then is a lot of databases are looking less towards being a specific type and more towards being a hybrid database. I'm primarily this database, but I'm also going to do that as well. So for example, a SQL database that adds JSON types, or a time series window, or adding time series window functions to a relational database, or adding a 2-column relational table to create a key value store within a relational database. We can see how we can take a regular database and kind of make it work in other environments with just a few tweaks. A JSON data type in a database is a great example here because I can create what is effectively a NoSQL database embedded in a column of a SQL database. Now I still get joins across all of my relations, but I may still have interesting query syntax into that JSON blob. I can treat it not just like a big string in a column, but like JSON data. That can be really, really cool. So as we look at this, as you're grabbing your camera to take a screenshot of the pics, this is a great one to grab. Here's a review of all of the different types of databases that we talked about today. One-line, two-line description of that database, and when you would want to choose that database as the database for this microservice. Now keep in mind, because we're using microservices, I can choose lots of different databases to accomplish the task, provided that I enroll each database in that mechanism for getting the authentication and the backup in place. And at that point, then my microservice owns that data. Relational data, document data, graph data, key value data, time series data, text search data. We can find the correct data store that matches these. So here's our architectures. We looked at that monolithic database underneath our microservices, and if we must go there, a bounded context is a really elegant way to solve this. Create a bounded context that outlines that portion of the data that responds to that this microservice owns, and that bounded context can keep track of that portion of the database. As we get to that level of automation, each microservice can own its own data store, and we can get to that spot here on the right, where maybe there are different databases in the same database server, or maybe they're completely different database servers to keep those data sources very isolated. We coined the term MicroDatabases here to outline that database that is owned by a particular microservice. When we get to that level of automation, then it's really easy to upgrade that database where we don't have to go check with all of the other people that might be reading and writing to this, because we know that this microservice is the only one tagged with this data. MicroDatabases. We looked at each of these types of databases, and the beauty here is that we don't need to choose only one. We can choose the one that best serves the task. Another magic question, well, how do we choose? Here's the other slide. As you grab your camera, grab this slide too. Or head out to robrich.org and grab these slides there, and you can get this content straight away. Here's my recommendations, and also recommendations as advised by Gartner. Ideally, you would use a database as a service. Now, database as a service is great because they'll keep track of all of the backup and restore pieces, all of the user authentication pieces, all of the uptime pieces. Never get woken up again if your database goes offline. You've outsourced that to your database as a service provider. Use automation if you're using more than one database server, because that automation can ensure that you have consistent backups, consistent restores, consistent user authentication, rolling secrets, whatever you need, that automation can provide that. By default, choose a SQL database. SQL databases have that ACID compliance, they're compatible. You can get a really good generic and general mechanism built into a SQL database. And then once you've got that solved for the other microservices where different data is best served by a different data store, then grab a different data store that exactly matches those needs. Now you may choose a different database type based on the needs of that data, and ensure that it's a really good fit, because you are, by choosing that different data store, sacrificing more generic things. Now you've specifically chosen that because you've specifically carved out that portion of the data that's needed for this microservice. Or perhaps a microservice needs more than one type of data store to be able to store different types of data. This was a lot of fun to review all of the different types of data stores, and in particular to review mechanisms of getting from monolithic databases to MicroDatabases. What are your questions?
Well, first of all, thank you for that, because that was really awesome to get that overview and to lead up into the MemSQL story and the new SQL databases. I think that was a really nice thing. But we've got one question coming in from the YouTube feed, and you may have already covered it, but just to repeat, what are the downsides to using new SQL over SQL? The overhead, network latency, and performance.
Yeah, definitely. Great question. When we looked at new SQL, a new SQL is that SQL engine, but not constrained to one box. And so we get a whole lot of benefits of a cheaper way to deploy. We can just add more commodity hardware to get more capacity to our database. On the downside, that one concern there is potentially network latency. We do need to coordinate between multiple boxes to do this. Now, arguably in our SQL databases, we're kind of doing similar things as we're trying to negotiate between threads or between simultaneous queries. So in a new SQL database, we'll likely get better performance in spite of that potential network coordination efforts.
So I think you did a good job answering the question earlier, and that. So if you go back to your recommendation slide just for a second, if you could just pass back there. One of the things that is interesting to me is this new database as a service. And as you know, an old school person, I should date myself with being a DBA for a SQL database back in the dark ages. So there's, I think the emergence of database as a service and how it simplifies things for developers. So being able to attach to the service and let the service provider manage and the distribution of the service and the security and all of that. Can you talk a little bit more about how that has changed things?
Yeah, definitely. When we look at database as a service, that's like one of the big things is, well, knowing that the data is my critical piece, I really don't want to let go of that. I really want to own that ownership of my data. Can I put it in a cloud and feel okay? Well, when we look at just comparing, I don't know, our office building versus a co-location facility, as we move to a co-location facility, we've chosen to outsource providing electricity and building security under the premise that that co-location facility is better at that. As we move then from a co-location facility to a cloud, our clouds, our public clouds, are going to be much better at physical barrier security. They're going to be great at that. We've also chosen then to also outsource backup and restore. That's one of the things that usually bites us is, well, was last night's backup okay? Most cloud database vendors will allow us to continuously back up. So, there isn't a big burden of time where we need to stop all the things and back up. And also point-in-time restore, maybe point-in-time restore to a parallel spot where we can now diff the data that we had together with the data that we used to have and find any abnormalities. Those are great capacities with a cloud database. Additionally, most of them offer, lots of nines uptime, at which point restore based on hardware failure is no longer a thing. I worked for a company where their server room was in the same room as the water main and the air conditioner.
Oh, no.
And everything else that wasn't people. And there was one interesting morning where they learned that the air conditioning vent had nicely leaked into the top of the server rack. Oops.
Oops. Yeah.
That doesn't happen in a cloud database vendor's mechanism because they're keeping track of all of those pieces in really elegant ways. Now, it does mean you need to let go, But I would argue as you think through those types of things, the things that you've chosen to outsource, you can now focus on solving the business needs that you have, not on solving for little things that you don't care about.
Definitely, I've been in those server rooms and seen that scenario play out badly as well. So there's another question coming in. For regular applications that are ported into cloud environments, which database would you recommend? He's currently running Oracle, aiming for Postgres for licensing reasons mostly, but is there anything you would personally recommend?
This is one of those touchy ones. As an advocate for MemSQL, I need to show you how easy it is to get started with MemSQL on Red Hat. If I go to the Red Hat Marketplace, I can just type in MemSQL, and here's that MemSQL database. From here, I just click Go and provision that database into place, and it'll keep track of MemSQL, that new SQL database, across all of the pieces, so that all of the pods in my Kubernetes cluster, in my OpenShift cluster, are accounted for. And that's really cool. It's really, really easy to get started there. Yeah. Ultimately, which would I choose? I would argue, what is the perfect size coffee mug?
There you go. And I think the other thing is it's matching it to your use case as well.
Exactly.
I think that really makes a thing. There's no generic answer for this. I think I definitely will have you back, and we can talk about some of the MemSQL use cases for ML and AI and all kinds of other things that I've seen you guys doing work on. But it really depends on what you're putting in that coffee mug, and which side the handle's on, or how many, or no handle, or what it is. I mean, it's really about the use case, and so there's not really a good one-off answer. But I do think easy to be deployed, easy to maintain, scales well. Those kinds of considerations are part of the first order of things that I look for, and definitely we'll have you back to do a deep dive on MemSQL sometime soon. And I really appreciate you taking the time today to answer these questions and to give us this tour de force on databases today.
Definitely. This has been a lot of fun.
I definitely learned a lot. I think one of the things for me is there are so many choices, and there are so many different use cases that it's really nice to see them all laid out this way. And so thank you very much. This is a wonderful was a wonderful briefing, and I can't wait to have you back again. So thanks, Rob.
If users have other questions that we didn't answer here, reach out to me on Twitter at Rob_Rich. Grab these slides right now at robrich.org, and let's continue this conversation, because this was a lot of fun sharing this knowledge with you. I'd love to continue learning with you too.
All right, we're gonna definitely get you back on. This was very, very useful. So thanks a lot.
I'm so glad.
Take care, everybody, and we'll talk to you all soon, probably tomorrow. So all good.
Thank you, everyone.
Good afternoon, good morning, good evening, wherever you are hailing from. Welcome. Thank you for joining us today on OpenShift.tv, wherever you are watching us from, be it Twitch, YouTube, or Facebook. We appreciate you being here today. I am Chris Short, Principal Technical Marketing Manager at Red Hat on the Cloud Platforms team for OpenShift. I am joined by my two fellow teammates today, Christian Hernandez and Jaafar Chraibi. I will let them introduce themselves. We'll do it in alphabetical order. Christian, you're first.
Alphabetical order. Nice. Thanks, Chris. Like Chris Short said, I'm part of the team. I'm a principal technical marketing manager here at Red Hat. We're actually all three of us here are team members, and I'll let Jaafar introduce himself as well.
Hi everyone. Yeah, my name is Jaafar, and same lengthy title as my two fellow colleagues. So. And yeah, basically I work on OpenShift. I've been doing working on OpenShift for the past 4 years, and I'm just happy to be here to talk about some stuff related to OpenShift 4, and especially infranodes and how we can tune the Red Hat CoreOS instances.
Sweet. So we're talking
a great show,
about what are we talking about today? MCO, right? The machine config operator.
Yep.
I think so.
Yeah. That's what I've been told.
That's what I've been told. That's what's on the calendar, at least.
Yeah.
What day is it? I don't know.
Yeah, no kidding. Oh my gosh.
All right. So what we have for you today is first. So I don't know how many people are here already. We don't know who already knows OpenShift 4 or not. So what we wanted to do first is a quick reminder of what OpenShift 4 is and how it works, talk about some architectural changes that we did between OpenShift 3 and OpenShift 4, and mostly heavily using a concept called operators, Kubernetes operators, that was introduced to the market by CoreOS formerly. And then after this section that I'll be doing, where I explain mainly the concepts behind the platform and the operators, Christian will actually show you how to use those to configure an OpenShift cluster and make some changes to the underlying OS instances that we will be using for that cluster. So I'm going to go ahead and share my screen, and please tell me, guys, if this is working correctly.
Oh boy, the screen sharing.
Hopefully. All right, here we go.
Hopefully. Anyway.
Yeah, this is like
Cross the fingers.
Yeah. All right. So first thing,
Uh-oh.
Here we go.
Technical. First technical difficulty. We'll see.
There we go.
There we go.
Yeah, you know, I think it's the first time I'm sharing my screen. Ooh.
It's always the.
It's the first time that gets you every time.
It's
you know,
and also not knowing what you're actually sharing.
I have to quit and get back, because if I wanted to.
This happened the other day. Yeah.
Yeah.
No worries, man.
No worries.
Yeah.
All right. See you soon.
We will.
Yeah. Zoom did some update or something to where like.
Oh, did it?
Yeah, like I guess it like some screen sharing mechanism like has to be installed now or something. I don't know. It's yeah. If you're on Fedora or whatever, you might have already done it, right? Like I don't know.
See, yeah.
Yeah, he'll be back in like 2 seconds. Yeah, there you go.
Yeah, there he is.
I'm there. Cool. So
Jaafar appeared.
Jaafar appears.
And I like his shirt. Man, I wish we had that in North America. I know that was an EMEA thing. That's a really cool shirt.
I love that.
All right. So can you all see my screen now?
Yes, sir.
It's looking
cool.
good.
Good. So let's go ahead. So first, I wanted to give you a quick refresh on OpenShift 4, and well, first on OpenShift, and then some changes that we introduced with OpenShift 4. So OpenShift, as some of you might know, is a platform that uses Kubernetes in its heart to help manage the container orchestration, but it's much more than Kubernetes. So as my shirt says, it's Kubernetes platform for big ideas. And by that, we mean that we want to give you a turnkey platform that provides you a lot of services that will help you deploy your applications faster, provide a better developer experience, provide some tooling for operators to view things like logs, have an integrated registry, etc. So all of these are the added value services that we provide out of the box with OpenShift. And one of the big changes that we introduced with OpenShift 4 is something that we inherited from the acquisition of CoreOS and their Tectonic Kubernetes platform, which was heavily focused on automated operations, what we call, so first, automated installs and automated day two operations. And that's what you can see in the middle. So this was heavily focused or heavily leveraging things like operators to ease management of components that are on the platform. And with OpenShift 4, we actually decided to embrace this notion of operators and extend it to the whole platform to manage all the technical components that we have within OpenShift. So one of the key components also that went in was the usage of RHEL CoreOS, which was the best of both container Linux that came from CoreOS and Atomic Host that came from Red Hat, which were both container optimized OSs. So with RHEL CoreOS, the goal behind this was to provide a sort of stateless OS for our container platform that will allow us to introduce a lot of automation capabilities, such as automatically installing the platform anywhere, whether in the cloud or on premises, on bare metal or on virtual machines, but also introduce some capabilities like auto scaling and stuff like that. So basically what this provides, if you compare RHEL CoreOS to a standard Red Hat Linux, is that RHEL CoreOS is an immutable container host. So it's heavily optimized to run containers. It's optimized to have a minimum footprint, but it's also designed in a way that is, I would say, an opinionated way of managing your OS. So you're not anymore the one who is managing the foundation of the platform, which is the OS, as you used to do with the OpenShift 3. It's the platform itself that hands you the underlying OS, and it's just another component of the platform services. So basically, we thought about what would be an ideal container host, and what are some of those characteristics that we would like to have. And these are a few of them, or the most important one. So we wanted to have minimal footprint, provide security, have an immutable host that will allow us to push updates in a seamless way that will not collide with any customization that you would have done on your OSs, and provide an easy way to update basically not only the OS but also all the components that will run on top of it. And we wanted to introduce also a better experience to configure the underlying OSs and make it more, I would say, easier to manage. So how did that translate into what we provided? So minimal means we're going to run containers and only containers on that. We're going to provide a minimal, I would say, attack surface by providing a heavily read-only and lockdown OS, except for some specific directories or folders that you would be able to change. And basically, it's gonna use containers anywhere for its configuration, for its updates, etc. So in terms of making it easier to configure, we wanted to have the ability to drive the configuration and the provisioning also of the OS from the OpenShift installer, and not have to rely on a pre-provisioned OS that some of the operators in your shop would provide beforehand, and have to install a lot of prereqs on top of that. So that was the overall goal. So making it as easy as possible to have new instances of nodes that run the containers. And that's, in the end, what the Red Hat CoreOS was designed for. So, yeah.
So, Jaafar, if I could stop you for a second.
Yeah.
Are these slides available anywhere right now?
Not yet.
Not yet. Okay.
Yeah,
So,
we could make them available afterwards. Yeah.
Yeah.
Definitely.
Cool. Thanks.
So, so basically, the Rel CoreOS has few components that we are going to talk about. One of these is the ignition mechanism that allows us to, I would say, bootstrap a new instance of a CoreOS and configure it without needing to store anything on it beforehand. So basically, it's just going to talk to a remote server that has files that says, here's the configuration that you need to apply to yourself. And the CoreOS system will do that and apply it at first boot. We're also going to talk about some systemd units. So this is something that Chris will touch upon, as this is what will allow us to say, here are the services that I would like to have running on my node or my CoreOS, for instance. And of course, it's going to have CRI-O as the runtime, Podman for managing the containers, and the kubelet running as a daemon on the host itself. And so without going into too much detail, some of these components are running as static pods, and the other ones are being managed by Kubernetes, like your workloads that you actually deploy on the node itself are being managed by Kubernetes. Of course, we use SELinux because we love SELinux, and it provides a secure experience for you out of the box. So as I mentioned, now OpenShift comes with its own OS that is just another component of the release. And for every OpenShift release, you're going to have the corresponding CoreOS version that is shipped by Red Hat, and that you can either download from our repos if it's a first install, or sometimes the installer can also do that for you. So you don't have to even care about downloading the first OVA or whatever. And if it's an upgrade, then we're going to apply the upgrade in a rolling fashion, but I'll be talking about it a bit later on. So how does that work? Basically, when you're going to kick off a new instance of your node or your OS or even the masters, they are actually going to use this ignition mechanism that says, here's how you need to configure your networking, here's how you need to configure your disk, here are the systemd units that you need to run. And basically, the OpenShift installer will create a set of masters, or with everything happening on the social media, maybe we should say control planes, and workers to actually run the workloads. So as I said, Red Hat CoreOS. Yeah,
I think it's important to note that also important to point out that Ignition runs before PID1, right? So it's like really, really early on. It's runs in init ramfs.
Yes.
To be able to, and the idea was, how do I set up my immutable file system for the first time, right?
Yes.
So that's that, and that's essentially the idea behind Ignition.
Yeah, exactly. Yeah. So you're going from, as I mentioned, a stateless server, meaning that you don't provide anything beforehand on the OS itself, and that's this mechanism that will store it in init RAM, make a first boot, apply the configuration, and then reboot to have the final things applied, like disks, networking, and stuff like that. So another important part is that it's an immutable OS, because we don't want to have all the fancy configurations or customizations that would prevent us from doing a smooth update of the platform. We know that customers love doing fancy stuff on their OS layers. But the problem with such a thing is that you cannot plan beforehand for every customization that every customer will be doing. So there's no way to actually control what's going to happen when you are going to ship an update for your OS. So that's why the Red Hat CoreOS provides you with a way to still make customizations, but with a mechanism that is outside of the Red Hat CoreOS, instead of customizing stuff on the machine itself as you would do with any regular system. It's something that you create outside. It's been held as a configuration in the OpenShift cluster, and whenever you create a new machine, it's going to pull this configuration or this customization to apply it to your nodes. So like the etc folder, the boot, or the /var are writable folders, but you can make those changes by introducing what we call the machine config operator, or the MCO. And basically that's what most of this session is going to be about. So okay, let's maybe go ahead. So this is an example of an Ignition file where it says we're going to declare a core user. Here's the SSH key that we're going to use if you wanted to be able to SSH there, etc. And basically, this Ignition file will be served by OpenShift to configure all the other components. So before going into details about what the MCO is or whatever, I think it's important to maybe refresh what operators are and how they work. Go ahead. Yeah, Chris.
We got a question in chat if you want to take it. Basically, the gist of it is, like, can you customize the cryo configs that are managed by OpenShift? They're trying to get support for image encryption. Can that be set up in OpenShift?
You can use disk encryption on the
right
on the underlying file system, right? So you can use the disk encryption on the file system, and if there's extra options, I don't know if we support extra options. So the answer is probably yes, from a technical standpoint.
I just don't know how.
But it's the
I think that there was a lot of effort introduced by the FIPS support.
Yeah, by the FIPS operator. Yeah.
Yeah.
I'm not sure if we like support in actually doing it. We may
with the machine config, you mean?
Yeah, with the machine config. Yeah.
Mm-hmm.
No, I don't have that info either.
That's a good question.
Yeah, that is a good question.
Yeah, we'll have to follow up on that. That's a good question.
Yeah.
I do not know.
So
And
was it
sorry.
a question from the chat? Or?
Yeah.
Okay. All right.
So
'cause I'm not.
Waleed's asking what is FIPS, and I'm just going to drop a link to the NIST thing. It's a encryption compliance standard, essentially, right? Like either you're FIPS compliant, either you're using FIPS compliant crypto libraries or not,
or
right?
not
Like
using the crypto libraries.
Toggle yes or no. You know.
All right. So are there any other questions, or should I go ahead with the operators?
Yeah, go ahead, bud.
Okay, cool. So this is a concept that is at the core of OpenShift 4. So I thought it would be good to spend a few minutes just refreshing what it is and what it's designed for. So what's an operator? I think you all know the operator with the lower O, which are basically the experts that are handling whatever stuff you need to do with your. So my face is turning white because I have this white slide showing up.
It's like really bright, right? It's like you're getting a tan. You're getting a tan after this, man.
So basically, the operator in the Kubernetes world is basically this. So you're getting your top-notch experts and putting them into containers. So all the knowledge that they have on how to exploit or how to manage a specific type of operations, whether being configuring OSs, configuring networking, configuring databases, configuring middleware. So all of that requires a specific set of skills. And basically the operator pattern is basically encoding this best practices into containers that will run aside your solution and manage its lifecycle and make sure that it's operating or working as it should. So the operators, so it's a concept that is now heavily used in the Kubernetes ecosystem. It was introduced by CoreOS, I think, in 2016, where they started maybe, I think it was with the Prometheus operator and stuff like that. And their goal was to basically make it easy for any end user to monitor applications by using a self-service Prometheus and be able to scrape metrics and stuff like that without being a Prometheus expert. So they thought about how they should make that easy for end users, and they came up with this notion of the operator. So the operator is a container that will have some set of logic that tells how to install a solution, how to upgrade it, how to make it resilient in case of an error, and stuff like that. And it's going to run as a container aside of the solution. So it also relies on the notion of custom resource definition, which is basically a way to extend Kubernetes to introduce some specific types that you would like to handle in a specific manner when you create them. I'm going to give you a quick example to make it a bit easier to understand. So say I wanted my Kubernetes or my OpenShift to understand a notion of cars. So Kubernetes understands pods, services, and stuff like that, but it doesn't understand the notion of what a car is. So to do that, Kubernetes allows you to extend the API to introduce new types of resources. And that's basically by defining a kind custom resource definition. And in our case, we're going to say the kind that we want to introduce is a car. Its plural is cars. Its singular is a car. And then by adding this extension to the Kubernetes API, I can now manipulate resources of type cars and do stuff like kubectl get cars or OC get cars. It's becoming now a first-class citizen of the Kubernetes resources. So that's basically what we did to handle all the technical components of OpenShift 4 by introducing custom resource definitions that handle the integrated registry, that handle the networking, that handle the ingress controller, which are our out-of-the-box HA proxies, and that handle the concept that we are going to talk about, which are the machine configs that say, here's how I want to customize the configuration of my CoreOS. So basically, we have an operator for almost anything we do in OpenShift. I think we have 27 operators as of today that are handling all the components. And Christian, maybe you're gonna scroll through the cluster operators window just to show.
Yeah.
How it is.
Kinds of stuff.
Yeah. Okay. Yeah. Cool. So yeah, just don't need to show it right now. And basically, one of these operators is the machine config operator. A machine being, if I took a shortcut, a machine equals a node, or an instance. And the machine config operator is the operator responsible for handling the configurations of our nodes, whether being masters or workers, or control plane and workers. So the way it works is the machine config operator relies on a custom resource definition, like we just explained. It's an extension of the Kubernetes API, and it's called machine config. So now whenever I create a resource of type machine config, the machine config operator can instantly read it, see if it needs to apply it to any subset of our nodes, and if so, it's gonna apply it. So we can configure stuff like SSH keys, or if we wanted to inject files at a specific location. So for instance, here it's just a simple example that says this machine config should apply to any thing that has the role worker, and it's gonna create a file in etc test. It's gonna use this mode, and it's gonna be a base64 encrypted content that says whatever we want to put in there. So that's basically how you can create a custom file on a specific path in your node. So the good thing with this is any node that gets created will automatically have this configuration applied to it. And that's the beauty of the machine config operator. It's basically you are creating a YAML file that says, I want to apply this config to anything that matches these labels. And whenever it matches, it's gonna be applied. So the good thing, so how does all of this work? Basically, we deploy a set of components. So you have the machine config operator itself, which is like the mastermind of all of this. And it deploys two things on the masters, which are the machine config controller, which is the brain that says, I'm gonna regularly check for whatever is defined in my machine configs, or something else called machine config pools that we will talk about later on. And whenever there's something for me, I'm gonna apply it. I'm going to do my job. The machine config server is another set of containers that are deployed on the masters. And they basically serve the configuration or the ignition files that the workers need. So they are acting as the repository for the configuration that is presented to all the workers. And something else that is deployed on the nodes, and actually it's going to be deployed on both control planes and nodes, because a machine config can be applied to both. It's what we call the machine config daemon. And basically the daemon is making sure that if there's a drift, it's going to be applied to the node and make sure that the desired state that we have described in the YAML file is actually the one that is going to be applied. So I don't know how much time. Maybe I'm taking a bit long. So, but it's we're mostly done. So
it's also important to call out. There was the spec we use for machine config is the same spec as ignition, right?
Yeah.
So it's ignition v2.2, I believe. So so when you look at the machine config, it should look very similar to an ignition file. So and I think that's what you're gonna go over in a little bit right here.
Yeah, exactly. So so we saw an example of how we can inject one file at a specific path, but you probably want to have several customizations that you want to apply to your nodes, and maybe you also want to control in which order these configurations are going to be applied. If you have dependencies between a DNS server or whatever you need, or an IPAM or whatever, you need to make sure that this is going to be applied before anything that needs this this configuration. So the way it works is by creating ordered names of the machine configs, it's going to be applied in a sequential order. All of the machine configs can then be grouped into what we call a machine config pool. And basically a machine config pool is something that says, well, first thing, so all those machine configs are going to be rendered in a, I would say, a mashed file that has everything, but in an ordered way. And if I wanted maybe to mix two configurations, say, for instance, I have this config that says apply to all workers, and this one that says apply to all machines that have this label role hyperf. How does this get mixed together to be applied? If I have a node that satisfies both conditions, well, it's going to be applied, as you say, in a chronological or in a ordered fashion. Yeah. So it's going to be it's going to take the 5 chrony from the first config, then it's going to take the 5 other stuff from the second config, and then it's going to mash it into what we call a rendered configuration.
Yeah, it's important to note that if you go back here, and I'll go over it a little bit when I demo it, but it's the last one is the one that gets applied, right? So
yes.
So the names are only for ordering purposes. There's no like, it doesn't do like a merge or anything of the file. So that is to say, if you have one file on the top that modifies a file and one file that comes at the end that modifies the same file, even though they're named differently, the last one wins. So,
yeah, exactly. It's the precedence.
Yes. So you have to be conscious of the ordered, right? It doesn't do a merge or anything like that. So you can actually like overwrite your files. You have one setting and one, on the top, and then you have a different setting that comes at the bottom one will win. So yeah,
sure. So that's why you might see I don't know what exactly you're going to show, Christian, but most of the times you might see stuff like 99 dash something to make sure that it has like a very high priority over whatever comes before.
Yeah, you'll see 99-ZZZZZ something, right? So, to make sure it comes at the end, right? So it's kind of like the old system V, the init.d, right? Like 99, HTTPD,
yeah, exactly.
init.d. So that's the same idea.
Yep. All right. So we spoke about the machine config, and I think I should have maybe presented this before, but anyway. So I spoke about the machine config server, which is basically running on the control planes. And whenever I kick off a new node, whether a VM or, well, let's just say new node, I'm going to be using a naked Red Hat CoreOS image that has absolutely no configuration at all. And I'm just going to say, please pick the configuration from this location, which is basically the API serving the configuration of the worker on the machine config server. And this is configured out of the box with the installer. So this machine would say, okay, please give me my config. It's going to give it this worker.ignition, which is a big JSON file that says, here's what you need to apply. And we're going to have the configuration loaded in init ram fs at first boot. And then it's going to reboot afterwards. And we're going to have everything kicked off by having containers start on the node and talk to the OpenShift API to say, here's my new identity. Can you please approve my certificate and include me as a new worker in the cluster and stuff like that. So what it serves for also is duplicating your nodes with the exact same configuration. But again, I don't have to put anything in the nodes. I just say, because as I said, we were targeting scalability and auto scaling and stuff like that. So now I'm just scaling infrastructure the exact same way as we were scaling pods. I'm just hitting count and say I want 10 nodes of this specific type, and it's gonna kick off the provisioning for whatever API is underneath, and then the workers or the new nodes are gonna get their configuration from the ignition. Yeah, we talked about that. The machine config daemon is the one that makes sure that there's no drift. It's monitoring the configuration and the states and making sure that it's applied all the time. Okay, so maybe if we have time, I have a few other slides that we can use, but I think that's about it. That's the main things that I wanted to talk about. Something to keep in mind also is that the Red Hat CoreOS is designed to ease the upgrade process, and it makes it incredibly easy to now upgrade OpenShift clusters. So basically, whenever there's a new update, I just go ahead and click a button. I go grab lunch or popcorn and watch it do the upgrade. And like 40 minutes after that, I have a new version of the cluster. And the way it's designed is that it's getting its upgrades as new containers that will be applied to the cluster and to the OSs. So yeah, without going into too much details, but that's about how it works. All right, so I think that's it for me. It took a bit of time, but I hope
Yeah,
at least it gave us a clear foundation to understand.
that's what I'm gonna say. We need that foundation, because a lot of the questions that come up is like, what's the difference between version 3 and 4? And there's really two big differences, but they're like big enough to where it's a paradigm shift, right? The two big differences, the immutable rel core OS and operators. That's really the big difference between 3 and 4, and but they're big differences, right? And it's really good to get that foundation.
All right, so thanks. I'm gonna stop sharing the screen now, and the floor is yours, Christian.
Yeah, so let me. Oh boy! All right, let's see if
shifting gears here. Here we go.
Shifting gears. Let's see if this desktop 3. So hopefully this is the one here. I'm simultaneously.
Hey, look, it's pictures of.
Yeah. Yeah. No, not that one. All right, cool. That's the right screen. Now I'm actually looking at the. I'm actually looking at the stream here. So I got a cluster up to kind of go over what Jaafar was showing, from a practical sense, right? So so if I do OC get nodes, you'll see that just like, actually let me sort by this here. I'm gonna sort so you can see I actually have infra nodes, and this will become important a little bit after as I'm going on, right? You'll see why I spun up infra nodes. So if you haven't seen the infra node stream, go ahead and watch that. I don't know how Chris, I don't know if you got Restream working. Maybe we should restream that one day.
Yeah, actually, I probably should just go ahead and queue that up to get restreamed.
And sharing the slides. Jaafar, I don't know if you have a people account on Red Hat, people.redhat.com. Maybe you can share it there, and we'll share the link somehow.
Okay.
Apparently on Content Hub, there's a way to do it too, but I haven't figured out how yet.
Yeah. Well, I think I mostly used Highspot for sharing stuff outside.
Okay. Yeah. No, that's good.
Yeah, I can definitely do that. No worries.
Yeah, if you could show me how to do that when we're off this call, that'd be great too.
Yeah, sure. We'll do it on the stream.
Yeah. Well, the good thing with Highspot is that you get some stats about what are the sections that are most interesting.
Yeah, we like telemetry. It's always good.
Yeah. So that's really interesting.
To know what's important.
Yeah. If you
to know the hard parts. Yeah.
If you see that a slide has been seen like for 1 second, it's not.
Yeah, you know that no one likes it. Yeah.
All right.
Cool. So so I have infra nodes, and I'll explain a little bit. But let's take a look at some of the things that Jaafar was talking about, right? So if I do OC get CO, CO stands for cluster operators, right? So so for OpenShift 4, we not only are using operators to deploy like application runtimes or like managing workflows, but the actual cluster itself, right? We went all in. It was like, well, you know what? Let's just use the operators to manage the cluster itself. And here are some of the things that get managed by the operators, right? So things like authentication, things like etcd itself is being managed by an operator. And one thing here, let me actually clear this and grep out. Even managing the machines is done by operators, right? We have the machine API operator, the machine approver, right? So once a machine is once a machine is up and tries to join itself as a node, there's an approval process. I kind of went over that briefly when we did, I think, the helper node stream, when we had to approve the CSRs, right? Like, so if you're doing a bare metal install, you need to approve the CSRs manually. If you're doing IPI, that gets done automatically. And then what we're kind of really dive into is the machine config, right? So the machine config, that's actually an operator as well. And so, so that the entire platform, we went all in the operator. So anytime anytime you have a question for OpenShift 4 about how do I configure X, the answer is probably an operator, right? So the answer is probably a CRD. You're probably submitting a CR somewhere, or you're probably modifying some sort of configuration somewhere. So the answer is always is how do I, the answer to how do I do X on OpenShift 4, the answer is 9 times out of 10, you're going to do something with an operator. So including managing the config, right? So we have the machine config. So if I go over to, if I do an OC get machines, right? You can see that I have these machines running. I have the infra machines set up. I have my masters and my workers. These are managed by the machine API, right? So it's really how they spin up and then they spin down using the machine API. They get their configuration by the machine configs, right? So if I do OC get, does MC work? It does work, but I'll do the long way. OC get machine config. Sometimes it's weird what works and what doesn't work. If I do OC get if I do OC get MC, that works. But if I do OC get cluster version, I have to type that out. Like OC get CV doesn't work. I don't know who decides what gets shortened and what does not.
Well, pods is shortened to PO, so.
Yeah, OC get, yeah.
I don't know if if you have OC explain or something like that. I don't remember exactly. Does it say
version?
Oh,
actually, if you do actually OC get, I know I did this the other day. OC get API resources or API something. Okay, resources. If I spell it right.
That helps.
Yeah, it's gonna.
OC API resources.
No get.
Yeah.
See, sometimes you get something, sometimes you don't.
Yeah. Like that always gets me. Get it?
That always gets it. Right? So in order to get your you get the
and you have the shortcut there.
Yeah, so they have cluster service versions is shortened.
Yeah, like if it's like 3 words, it looks like they shorten it. If it's 2, they might. If it's 1 word, maybe.
Actually, maybe. Actually, can we? I'm gonna go on a tangent. Sorry, I'm just curious.
Do it.
I'm gonna do OC edit API resources.
What?
There we go.
Okay. It didn't let me. Okay.
Yeah.
I was just I was curious if I can edit and add my own. Actually, OC get CRDs, right? Is that what it is? Aha. So I'm like in the middle of a hacking thing right now. So
I love it. I love it.
Let's do that. And then we go down.
But you need to have a look at one that has the shortcut.
Oh, this one doesn't have the spec in it. Yeah. So which one?
Yeah.
So
what does have a shortcut?
OC edit. Well, we did machine
CSV.
Or machine config or
MC, right? So machine config, there it is. That one has one. So we're just gonna take a look at this one. Oops. Whoa, that looks crappy. Okay, let me go down.
Yeah.
There it is.
Search for MC. Do you have?
Yeah.
Well, MC, there's a lot's gonna come up here.
Oh,
yeah. Well, actually, not that many.
I actually messed up. CRD. There we go. I was looking at the wrong resource. Spec. There it is. Conversion. Yeah. Short names.
Short names. I like that.
So
full of puns today.
Yeah. Spec.
Spec names.
I'll just copy this. Actually, let me open a new window. Okay, so then I do OC get CRDs.
So what Christian's actually doing right now is editing the CRD to add a shortcut, an alias essentially.
Yeah, I'm just curious.
To create so he doesn't have to type in all this stuff. You can do this on your own too with anything that you want to create a shortcut for in theory, So,
yeah, for your own cluster, yeah.
Yeah, if there's some command that you constantly have to type that you don't like, this is how to create a shortcut for it.
So it's short names, plural.
Yes.
And it's under names. So it's names, short names. Okay. Oops. Is it short names like that?
Yep.
Yeah.
Yep.
Yeah, and then
Underneath.
MC. Oh, MC. No, cluster version CV. How about that?
There you go. Yeah.
So hopefully there's no okay, OC get CV. Okay,
Oops.
well there we go.
Check if
Oh, wait,
there's
don't you have to see if it
check if
reloaded?
there's an operator upgrading or whatever. Maybe the
Yeah.
API server. Check if the API
Yeah,
server
like,
is updating.
Did it pick up the new version yet? Yeah.
API versions, rep, cluster version.
It shouldn't be a kill pod. The pod should just restart.
Yeah, exactly. But if you go to the, check the operators and see if anything is upgrading.
I forgot what it's called now. Get CRD rep cluster. I know I'm on a tangent now, but I'll probably stop if this cluster version.
You spelled version wrong.
Cluster V. Okay,
There you go.
CRD.
So 44, I mean, no, that's old. It didn't change.
Yeah, maybe I messed it up.
Wait.
Short names. Yeah, it's not there.
Oh, never mind. Sorry. Yeah.
You may have not taken it. You need to kill it.
It might not have.
Yeah. Kinds.
Yeah, no.
Short names. Oops.
Yeah.
And I forgot, is it here?
Yeah, there. CV.
So C this should do that.
Clever.
Yeah.
Clever.
Clever. Yeah, clever. All right, copy. Edited. Okay.
But yeah, it's not.
Doesn't have resource. Oh, there it is.
Yeah. Oh, now it goes. There we go. Cool.
There was probably like a conflict somewhere with CV. I don't know.
Nah.
It was the longest shortcut.
Yeah. So I don't know if this is helpful because I don't think I remember clever. I guess maybe clever. I'll keep it.
I would remember clever. Yeah.
Yeah. Anyway, where was I? OC get machine.
It's a good hack. It's a good thing to know.
So if I do OC get MC, that'll give me the machine config, right? So back to the subject at hand. So this gives all the machine configurations, right? So it has, and these are individual configurations that are loaded in this order, right? So like it'll load 00 for master, 00 for worker. This is the one that Jaafar was talking about, like 99 master SSH. So if I actually take that, if I do an OC get master SSH, get machine config -o YAML, you'll see the configuration here. It looks very much like Ignition, right? So you'll see the Ignition configuration. You can actually just take the Ignition configuration and actually just probably copy and paste it down here and it'll take it. And it is, version 2.2, and then it gives the SSH key for the core user, right? So if you ever want to, like if you need to rotate your SSH keys, right, for security purposes or anything like that, you would actually just edit the machine config, right? So you'll edit this machine config here for the, one for the master, one for the worker, and then all your machines will just inherit that. And so there's also here another machine config that's actually related to the machine config pool, right? So for example, this one here, this is called the rendered worker. Let me do OC get machine config rendered worker. And this is, as Jaafar said, the complete config for the worker, all squished down into one large Ignition file, right? So this is everything that gets loaded into for all the workers, right? So this is the squished down here version. And this is managed by the machine config pool, right? So if you OC get MCP or machine config pool, I know Andrew's watching. That's why I'm getting all my misspellings in.
Yes, it's all Andrew's fault.
And so the machine config pool.
You didn't put the capitals at the right places for Andrew.
Oh, that's right. Yeah, that's an inside joke, by the way. Can I do that? Oh, that does work. Okay. Does the first one capital work? It does, right? So it just takes it. I guess it just does a.
But is it compliant?
Is it compliant? We're not sure. Machine config pool like that. Does all caps work? Does that work? Well, yeah, it just takes whatever. Anyway, machine config pool, and the worker here. If you do that, I do OC get machine config of this. This is how the mapping happens, right? So the rendered worker hash is what Jaafar said, that squished down version, right? The one with all the configs all in one file, and it's managed by the machine config pool. If I do an OC get machine config pool MCP of the worker, dash o YAML. If I go up here, it'll in the spec, right? It says, there it is, machine config selector, right? So it says anyone that's that has the role of worker, right, and has the node label of worker, apply this machine config to this worker, right? So the configuration is rendered worker, right? So again, the machine config pool says, okay, anyone labeled a worker, apply this machine config. So, so then now.
So one is to select the node, and the other one is to select the set of configs to apply.
Correct, yeah. So and it'll apply that to the to those nodes. And one thing, actually, I want to show how. If I go, I don't know how to do this, but I know where to get it. I've written this down. What's the API endpoint? 22 something or other? 22.
No, the API.
The machine config API.
Ooh, don't know.
22. I think it's 22643.
22643. Just do that. I wrote this down somewhere. I just forget where. Maybe it's in my NCO notes.
Is it for the ignition?
Yeah. So the machine config API.
Okay.
You can actually curl it.
22623.
Yeah.
22623. You said okay. 226.
That is from Andrew in chat. Thank you,
Andrew. Thank you. There we go.
Yeah. If you look at the slides, it's there. Yeah. 22623. Exactly.
Well, I guess I didn't write it in this repo. Okay, so let's see if I can do this by memory. So if I do curl, HTTP, actually I don't need the -k, HTTP.
So you're looking for the API int stuff?
Yeah. So actually I need to do, that wouldn't be available outside. We'll see, get nodes. We'll see debug node. By the way, this is how you log into your one of your nodes, because you're not supposed to SSH into it anymore. That's another paradigm shift, right? That you have to think about OpenShift 4.
Yeah, like with OpenShift 4 and the underlying OS kind of being managed by the platform itself, SSHing into nodes is kind of a bad thing, right? Like you don't want snowflakes. We intentionally prevent snowflakes. So yeah.
Yeah, you'll get it'll get tainted.
Yes,
as a result of it. By the way, so OC status, OC info, OC cluster info. There it is. So I'm looking for copy link. All right, this will it'll be made apparent here. So API-int.
Yep.
And then it's
22623
623
/config/worker.
config worker. There we go. Thank you. Can I resolve API-int? Why not? Oh, I know. Probably know why. Can I just do API? Yeah, because this is using it's using that new. Yeah. So how would I? Can I do this outside the cluster?
You can do it from a pod within -K. Yeah.
Yeah, I don't think that port's open. So what I'm going to do
No,
is
no,
I'm actually...
but no, it's not going to work that way.
Yeah, I have another cluster in my own home network, so I'll just use that one for this purposes here.
There you go.
OCP login. Okay, let's see.
Yeah, let me check if I have one handy too.
Curl. All right, so it's API OpenShift. Okay.
Triple Chin in chat says yes, you can. We're just going to jump around.
There it is.
There we go.
So so what happens when the machine comes up? It'll ask for its config, and it'll basically curl. It'll curl this worker here, and essentially this config here is the ignition file. I think I can JQ this, right? JQ-R. There we go. Yeah. So it's the JSON file for the ignition file, and then in that worker, that curl command from that config/worker is a is basically this file. Get MCP worker, not MC MC.
It should be API int. API works for @Christian because they are the same in his deployment, but they are different load balancers. It wouldn't work.
That's correct. Yes. So I got to point that out. This is my internal one. So whether I use int or not, it's pointing to the same. Could not resolve API. Oh no, I took that out. Yeah, there's no API int. This is IPI. This is VMware IPI. Yeah. But whatever what Andrew says is true. Yeah.
Whatever Andrew says is true.
Well, no,
I'm just gonna run with that from now on.
Yeah, whatever Andrew says is true.
Yeah. He's got that on camera now.
Yeah, because he's right. It's just my stupid little network here. I do dumb things. But yeah, so that's why this is essentially so that curl command gets this file worker and applies it, right? So the caveat here is that, and going back to the infra nodes, right? What's it called? Sort by. What if I have a config that I only want to apply to a subset of nodes?
Oh,
right?
Triple Chin pointed out something.
So,
for OKD4, sorry to interrupt you. For
no, go ahead. Yeah,
for OKD4.5, you have to set the correct user agent, else it won't work. So if you look at the curl-k user agent thing you put in there, that's interesting.
User agent, really?
On a 4.5 OKD box, though.
On OKD 4.5, interesting.
Yeah.
Because I'm on OCP 4.5. I don't have to do anything on that, any of that stuff.
Yeah.
But that's good to know.
Yeah,
it's good to know.
That is good to know. Yeah.
That'll probably be in 4.6. Yeah. So the challenge with the machine config pools is that they are going that if I just want to apply configuration to one node or a subset of nodes is you can't do that with the built-in machine config pools, right? So I have anything that I apply to this worker machine config pools, all the workers are going to get all of them, right? And so this is kind of this presents a challenge, especially if you're going to use machine config operator to set up like a second network card, right? Mm-hmm. So like you can set up a separate static. You can set up a separate network card if you're going to do DHCP, right? That works fine. But if you're going to do static IPs, you can have the same static IPs going across all workers. That doesn't work, right? So, so what I have here is you need to be able to create a machine config pool that targets specific nodes, right? So if I go to where am I here? I'm in infra nodes. I want to go to Twitch. Yeah, in Twitch I have machine config. Oops. Machine config full example, right? So let's take a look at. So I have one file, but it's actually two configurations. So let's take a look at that. So between lines 2 through 12, right? So I'm going to create a machine config pool, and I'm going to call it infra, right? So this is going to be specific to my infra nodes. So I'm going to have a machine config pool specific to my infra nodes. I'm going to match the expression, right? So I'm going to target the machine config role. I'm going to target the nodes that are labeled worker and infra, right? So that's how I have my infra node set up, right? So I want to match anything that either has either worker or infra, right? So that's one. And two, but only match the labels with the nodes that have infra on it, right? So I'm kind of going big to small, right? So I'm going to have first look for the ones that are only labeled worker infra, and from those only target the ones that are labeled with a node role infra. So I'm going to create a machine config pool that does that. So now the second part is I'm actually going to create a machine config. And in that machine config, I'm going to add configuration files, right? So here, as Jaafar said, here I'm putting 98 infra config just because I just want to be different. You could most likely you probably want it 99 because you want it after the machine is actually up and running. If you have some lower level stuff, maybe you'll have those things come up before, especially if you're setting network configurations. Actually, I actually wouldn't set up network configuration using machine config. Andrew probably knows where I'm going with this. Is the easiest way to set up network interfaces, just kind of a side note, is using the NM state from Kubernetes, right? So, and the way to get that is you just install the CNV operator, even though you're not going to use it, just so you can get the NM state objects. That's probably the easiest way. So you probably still could do IP network stuff with machine configs. I just personally wouldn't do it that way. So that was one tangent. So here in my machine config, I'm going to say, okay, target the machine configs roles of infra, right? I'm using just ignition. And then I'm going to write out two files, right? I'm going to write foo conf with this base64 that I changed because it says something else earlier. And then foo other, right? So you can kind of just see using the ignition spec, you can actually do you can do a lot of things, right? So just using the regular ignition config, you can start writing out files, right? Instead of actually manually creating those ing files on boot. So this is very easy, right? So this is kind of a simple use case to kind of just get your mind familiar. Targeting worker infras, and from that, I'm only targeting the infra ones. So if I do OC get nodes, I have three infra nodes. If I do OC create, right, machine config pool with the machine config, so I'm going to apply those two configurations, and those two are now applied. So if I do OC get machine configs, you'll see that now I have a infra config right here, right? Get machine config infra, you should be able to see the file, the spec that I provided. Also, if I do OC get a machine config pool, you should see there's a new pool called infra, right? If I could do OC get MCP infra node, you'll see that that spec that I was talking about is there. Where am I? This new fields type thing from Kubernetes 1.18 always confuses me because it has the config twice, but whatever. There it is right here, match expressions, worker infra, but I'm only targeting infra. One thing to note, these will reboot. So the anytime you write out a configuration, you see here it says ready, scheduling disabled. What's going to happen is that it's going to, as Jaafar said, it's going to apply this configuration in a rolling fashion, right? So it's going to mark it as unschedulable, right? Make sure everything's all drained out. It's going to apply the configuration and then reboot. So reboot basically so that way you just get a clean configuration. So what's happening here is if I OC get pods, here we go, machine. There is, actually, is it daemon set? Yeah. So there's a machine config daemon, right? So there's a on all the nodes there's a pod running, the machine config pod, and that it's a privileged pod, and it's all its job is doing is to make sure that machine config gets applied to the node. So once it does that, it'll reboot it. Get nodes. See, we got so that's 2, right? So 2 down. This probably be a good time to we can see if there's any questions.
Yeah, some are rolling in right now. Hang on.
Andrew's pretty good, doing pretty good at
yeah,
Christian broke his. Yeah, I did break mine.
Yeah, you did break your thing. By default, machine config will do one node at a time. You can customize that value using a specific number or percentage in the NCP definition.
Yes.
CUA 55. Is that you, Jaafar? Yes. Okay. No questions. We're good. Go.
Cool. Thank you, Andrew. Yeah, that's good to point out as well. You can specify that. If you want to do them all in one shot, you can.
Yeah.
I wouldn't, but
I wouldn't. But yeah,
I mean, to
can.
test, yeah, you can. Yeah, you can see what works for you.
Break it.
Yeah, break it like I did my cluster. Remember what Andrew says is right. Okay, so now it upgraded and added those files, right? So if I do OC get nodes, let's look OC debug node. Let's look at this infra node, right? So let that. I need you to tell my kids that I'm always right. Eat your vegetables.
Go ahead, put them on. Put them on.
Put them on.
You can join the Zoom call real quick. We can make this happen.
So here, so now I am in this the infra worker, and I'm the cat etsy foo, right? foo.conf. OpenShift's the best Kubernetes platform, and then foo other. Red Hat is awesome, right? So I basically wrote those configurations out using the machine config. If I actually go, now let's actually go, actually I have it up there, OC debug node of let's go to a regular worker, right? So let's go to regular worker. So remember, I actually did target worker in my machine config pool with that machine config label, but then further down I said, but match the role of infra, right? So the config shouldn't be on a regular worker, right? So let's do that. So let's chroot to host. I always do bash afterwards, so I get the nice little PS1 prompt. So if I do cat etsy, let me just copy pasta here. Foobar, no such file or directory, right? No such file or directory, because I'm only targeting my infra nodes. And then let's see, get. So there you can see how you can create a custom machine config pool to target the specific nodes in your cluster for specific configuration. And this is there's other things you can do, right? So there's like kernel parameters. If we look at the docs, of OpenShift.com. And then let's select the
Okay,
version.
so here's a question. How can we add infra node labels on OCP4 post installation?
Infra node labels. So it depends what you're doing, right? So for
Post installation. So
yeah,
like
so
the
for
node's
post,
already up and you're converting it.
yeah, so if you're doing an IPI configuration, so like the automated installer, fully
Right.
automated installer, whether you're on AWS or GCP or whatever, right? Machines, no, machine sets.
Yeah,
You would just create a machine set for the infra.
right.
You basically create a machine set, and then you do an apply, and it'll create that machine for you. If you are on, like, let's say the I'm gonna use Andrew's verbiage, the non-integrated UPI install method, right? So if you're gonna do the installation with no cloud, you would basically install a worker, and we do OC get nodes, and you would do OC label node. By the way, this is not going to work, but I'm going to show you how you would do it. You would OC label node, and you just pick a node, right? So let's just pick this worker, even though it's not going to work. And you want to add the label node role Kubernetes IO infra, right? At least, oh wait, it doesn't take the -L, just like that. At least one label update. See, label node.
Is it already on there?
I did this. This worked earlier. Label row.
Equals.
Oh, I need. Oh, that's right. It actually equals nothing, right? OC. So this node is labeled, right? It says it's labeled as infra. But if I do OC get nodes, I wonder if the operator. Why didn't this work earlier when I was doing it? I'm surprised this worked now. Get nodes. I'm gonna be completely honest with you. I'm surprised this worked now because maybe I was doing something with operators and it didn't work.
Possibly.
But you just add the but long story short, just yeah, it's magic. It's FM as my
yeah, FM. That's
it's
right.
FM as my as one of my ex coworkers used to say. You just add the label essentially to the to your worker. Whether you're on IPI or UPI or bare metal, Christian's always right. Christian's always wrong apparently in these streams because it when I was messing around with this, it didn't work. But maybe I wasn't. Maybe I forgot the equal sign last time.
Maybe.
Yeah. So this is actually might fail because there was actually workloads running on that worker, and infra has a taint. So if I do, let's watch this. Let's see how long that takes. See any more questions here? Yeah, you'll need to use taints.
Yeah. Andrew kind of answered it, right? Like you got to create the config itself, right? You got to create a MCP for it to persist.
You have to. Oh, look at that. This is ready. So now I have 4 infra nodes. There we go.
Ta-da!
Ta-da!
Magic.
So I can actually remove. So if I do, oh, you know what doesn't work is removing the label. Okay, this is okay. So because someone mentioned, so okay, so I
once
was
it's an
right.
infra node, it's always an infra node.
Well, no, yeah, I was right. I was right, but not in the literal sense. So if you want to remove, right, I want to remove the worker label. I think it's just key, right, like that. LC label node. Label node. Oh, it's on this side. I always forget where the minus goes. OC get nodes. Well, that does work. So what was I doing? What was I doing last time? That like I was actually, I wanted it to work and it didn't. Now I don't want it to work and it does. But now it's only getting the label infra. The problem with this, right, is when upgrades come along, it won't upgrade this node because there's no machine config pool for it. But since I have a machine config pool for infra, it'll just in this instance it'll work because I have a machine config pool infra OYAML that includes itself in the worker role by doing this. Where is that config? Right there, values worker infra, right? So, yeah, to get nodes. And your infra nodes doesn't count towards your subscription cord. So,
yeah,
I'm actually glad I tried this. Because it looks like it does work. I don't know what I was doing before. Maybe I was just playing with my broken cluster.
Maybe.
I appreciate your genuine surprise that it worked.
Mm-hmm.
Yeah.
I was going to let you read that on your own.
Yeah. Yeah. Because I guess, yeah, I guess when I'm testing stuff, I shouldn't test on my broken cluster. I guess is what the what the
general consensus would think. Yeah.
Cluster. Is there an update? Let's see. ADM update. I want to see.
Upgrade.
There's nothing 452. I don't think there's a 4. Is there anything in the fast channel? Good old Rob Siminski's.
So Christian, also, if you check your machine config pool, you can see the number of machines that are affected by it. So you can check if your infra.
OC get MCP. You see it?
Yeah. -O, like your infra. Yeah, you can see the machine count there.
Yeah, machine count, ready machines, updated machine count.
So that means that your new one is part of this machine config pool. So
yeah, my new one has inherited just because of the labels, right? So I added a label and then all of a sudden so that new one, OC gets nodes. If I do OC debug node, then it should.
So yeah, you can check if it has files that you created.
Yeah. CH root host and this cat etsy foo.conf OpenShift. Yeah. So by changing the label, that configuration then appeared on that node. So what was I
and what you can try to do?
I don't know, something else.
So if you manually delete the file from the node, is it going to be reconciled?
Let's do that. I actually haven't tried that. I just hope it will always be there. Let's see.
I think it should.
Cannot access. Okay. I don't think there's anything that triggers it though, right?
I think the controller should pick it up at some point.
All right, so let's keep a watch on that. Because in theory, it should say scheduling disabled.
Or check the daemon logs.
Oh, for the we'll see get namespaces machine. Which namespace is it? OC.
It's the OpenShift machine config operator.
I'll just go to that. I'll just go to that project. Let's see. Get pods. Which one?
Yeah. So
the controller. The controller or the operator?
try either. I was thinking about the daemon to see if the daemon
oh, the daemon. Oh, okay, for that specific.
Yeah. For that node.
Okay, so we're OC get nodes. This guy, right? So if I do OC get pod wide.
Yeah.
Grepo for this guy, so OC logs for this daemon here.
Yep.
Is it -C for container?
Yeah, -C, yeah.
Okay, here. Validate on this, completing pending on this. In desired config rendered. Doesn't look like, because this is like the first boot here, looks like. Enabling kubelet, current config, desired config. Yeah, see, here you can actually see it working. So here, the current config, it says it's this hash for the worker. Desired config is this hash, this for the infra, right? So now I need to change that on the disk, right? And then validating against pending config. It validates it, completed update. So it doesn't look like
it picked it up.
Doesn't look like it. It's interesting. Because I would think OC, let's see here, debug. Let's take a look. chroot host. Yeah, it's just foo other there. So let's do this. Systemctl reboot. Let's like the really. Let's see if a reboot helps it. Let's see, get node of this guy here.
Yeah, in theory, the reboot should.
Yeah, let's see if the reboot helps. Yeah. Well, so the reason why, so the reason why I was able to, like, some people are probably thinking, like, you said immutable file system, but you're able to remove a file. As Jaafar said in the presentation, and we'll get that out to you guys. Chris Short will tweet it out. Yes. Certain directories are read and write, and Etsy is one of the directories that you're able to read and write. So that's why I was able to remove that file from Etsy. So, so status not ready. All right, so it's in the rebooting phase.
So it is moving. I mean, this thing is plugging along.
It's doing something. So it looks like if there's a discrepancy or something, you probably need to reboot the MCO. So I wonder since it's based on ignition that it only runs once. That's a good question. That's something I'm going to talk to the engineers about. So I'll tag you, Jaafar, when after the stream when I ask them the question. Because I'm with you, Jaafar. I think that it should have like detected that like that file is gone. I don't know how. Yeah. I'm just saying from a operational wise, it should have detected and it should have just rebooted the machine.
It's also maybe a matter of just, how frequently is the reconciliation loop.
Yeah, that's true.
And maybe you need to wait a bit to have it applied.
Yeah, how long that loop takes. So let's cat etsy. It's actually ls. Let's see, foo. No.
Okay.
I rebooted it and it's not there. No bueno. So I would think a reboot should have handled that. Interesting. We're finding things out today.
Yeah. Learning is real.
The learning is real. So I wonder, let's do this. Let's
I'm pretty sure if you change something in your machine config, it's gonna be updated. But
Well, that's what I'm doing. I'm just gonna. So I took out the label.
Yeah.
Yep.
I don't know, and then let's.
Yeah, if you label it again.
So you get nodes. Okay, so that's there. So let's do a watch, and then see if that triggers it, or like make an update to the config. That'll definitely trigger.
Yeah.
it.
Yeah. Exactly.
Yeah.
Like it's well, that's. I wish I was in Tmux. I would have added another. Let's just do this.
There you go. Just add another terminal.
Yeah. Let's do. Let's see here. Oh, now I know what to do. It's always right. Base 64-W0. All right, so that's. So I didn't see it reboot. All right, so this is discerning.
The joy.
You know why? Because maybe the ID of the machine config
hasn't changed. Yeah.
Hasn't changed. So
yeah, interesting.
It might be considering that it has been already applied.
Yeah. So actually, I think that's exactly what's happening. It's the hash, right? So it says the hash applied, and this is what you wanted. Okay, like there's
And
nothing
it
for me
didn't
to
change.
do.
Yeah.
It didn't change. Yeah. So if I do OC edit machine config, OC get machine config, OC edit machine config 98 infra config, and I'm going to change other foo to Andrew is right.
But yeah, okay.
And that should change the hash, right? So this is
yes.
So infra. So infra hash was this guy. Just copy it so I can get it. We'll do OC get. I don't know why I did that. Machine config. And so the infra looks like it stayed the same.
No, you have a new one.
Oh, I have a new one. Yeah. So I have a new one now. Yeah. Okay. And OC get machine config pool. The desired for machine config pool is. So it might take a while for it to.
Yeah, because you see it's updated now.
Yeah, machine count 4, updated machine count 0.
Yeah,
so
but
if I do OC get nodes. Yeah,
so it hasn't. Status says updating, so
yeah,
it picked up the
updating equals true.
The config change.
So this will do in a rolling fashion here. So come on, chug it. I wonder if it needs to do a reboot. I think it always does a reboot, from what I understand.
Yeah, it would.
Because it'll do a reboot. It'd be nice if it knew when to not do a reboot and when to do a reboot, right?
Now you're just asking for too much.
Yeah. Well, I mean, the logic for that might be crazy because what do you consider a reboot versus not a reboot? That's that's a long conditional statement, right? That's not.
But then you're introducing, I would say, you're opening a door for inconsistency because
correct.
That means that you are making in-place changes to the node.
Yeah, someone says in a big enough cluster, rebooting doesn't really matter. That's true because the workload should just move around.
Right. Exactly.
So in ideal world, right, you have enough workers to where the workloads will move around. So that's the idea, right? So that's the you can move that workload around to do maintenance like this. So I don't think it is it rebooting. Let's go OC get MCP. Let's do it. Still updating. Whatever it's doing. Who knows? Does the events give me anything? Oh wait. For whatever reason, oh, by the way, candidate 4.5, it's at 453. So if we want to test an upgrade,
Nice.
we can if we switch to the candidate 4.5 channel. Toolbox, where's my toolbox? The events is never sorted the way I like it. And I don't know, there we go. Sort by metadata creation timestamp. I always want it
Yeah.
in
The
a
latest
specific,
one.
yeah. The latest at the bottom is what I want. So 4 minutes, 9 seconds ago. So the let's see, OC gets nodes. Yeah, says a guy with 6 workers. Yeah, yeah. Go ahead,
Yeah.
destroy everything.
Burn it down.
Yeah, OC get machine config pool. It's still at 0.0. Yeah, I wonder why I updated. I wonder if OC get machine config pool. Can I kick this? OC edit machine config pool infra. This is why my clusters break. I just keep like poking. Jafar knows, right? Like when you're in this when you're in this job, you just basically your job is to break things.
I break things for a living.
I break things
Yeah.
for a living.
We
Yeah,
want to
Yeah.
know what works and what doesn't.
yeah. I want to know what works and what doesn't exactly.
For many reasons. For many reasons.
Oops. Let me see here. Let's see if I can just force feed this guy here.
So
this
Andrew
is the-
wrote a large paragraph in chat. I'm sure he wants me to read it.
Read it. Yeah. Well, I'm trying to figure out what's going on here.
So it's directed to Streppel Chen. Big clusters have other problems with regards to reboots, though. If each reboot takes 5 minutes and there's 100 nodes to reboot without adjusting the max nodes affected, it could take 10 plus hours to accomplish when doing sequentially. This gets particularly troublesome with physical nodes, which can take much longer than 5 minutes to reboot. Planning and controlling updates, MCP changes, etc. becomes important to avoid too many different config versions in the cluster. Is there a reason why kexec isn't used for MC updates? That's from Streppel Chen.
That's really a good question. Let's see here. I think they were planning on doing it. Yeah. I think I know they were talking about it, right, in the chat with the engineers. But I'm not sure where that is on the roadmap. That would be what was I doing? Yeah. So I'm going to change this and just see what happens. Canceled. What? Change, paste. Oh wait, that's the same one. Okay, so it does have. So maybe it's just taking time.
Mm-hmm.
Did it change the ID?
So it says config 5.1, but we want 0.3, right? So if I go, if I edit that, edit config 5.1, 5.1, 5.1, 5.1, type degraded equals true. Okay, that's, so this is the status one.
Oh.
So here it says it wants, the configuration actually does want that. It's just not sure why it's not kicking off. Huh. I wonder if we I wonder what Jaafar says is true. It's just like that reconcile loop. I wonder why it's not rebooting. I changed the machine config.
Yep.
And then.
So it rendered a new.
And so it rendered a new machine config pool, the squished, like you said, the squished version, right, of everything. there. Machine config pool, although it's not displaying it here. If you actually look at the YAML, it is there. So there's, okay, interesting. Degraded machine count equals 1. I wonder if that's if it's choking on this infra one.
Maybe.
So
what does Andrew say?
What does Andrew say? Whatever Andrew says is true. Because if you see here, there's it's kind of hard to tell because like the way this is spaced out, but it says degraded machine count for infra equals 1. So I wonder if that's like pausing everything because that file is missing that I shrugged. And Andrew says shrug.
Super
because
helpful.
of that file that's missing. So what I'm gonna do?
Can you check the logs for the operator?
Smooth operator. Okay.
Smooth
There it is. Yep. Validating against current config. Could not stat file foo. ls stat. No such file or directory. Marking degraded. Unexpected on disk state validating against rendered blah blah blah. So it validates it after the fact. Interesting. So long story short.
So it noticed that the file isn't there. That's a good.
Yeah.
That's a start.
That's a start. Yes.
Okay.
That's right. Why it's not reconciling it?
Marking degraded due to unexpected on disk state.
Yeah, it gets stuck. That's exactly it. It gets stuck in the. So that's why it's not rebooting, right? It got stuck. It goes, oh, there's an error here. The file's not on the disk.
And can you go up and see what?
It keeps so here. Yeah, validating against the daemon says validating against file 1 could not stat file. Unexpected on disk. Yeah, so he just keeps, and that's.
So it does it pretty frequently. Okay, so go ahead and touch your file on the node.
Yeah. So yeah, I was thinking I can either.
Oh.
Yeah, just.
I can do one of two things. I can either touch the file.
Yep.
Or I can remove the infra label from that. Which I think touching the file is a better idea actually.
Just to see if it picks up.
Yeah. What is this here?
Flip a coin.
Debug. I wanted to know which one would be better to.
And you know what could be tricky is if it's using a hash to check that it's the right file. It's not gonna work. But let's just keep trying.
Yeah. We'll touch this file. Yeah, we'll touch this file.
May the force be with us.
Yeah, these are steps that I would do, right? Like if I was an admin, I'd be like, I wonder what would happen if I just touch this file.
Yeah, exactly. And we're just not afraid to do it.
We're just not, because it's not a production server. Yeah. Gets nodes. Okay, so then logs. Okay, so that's. It looks like it does pretty frequently. Looks like.
It's like every 8 seconds or something like that. Oh, even no. Every second.
Not stat file. Okay, so it's a current content mismatch for file.
So at least you know that if someone messes with your config file, so it's basically using the hash of the file.
Yeah.
To check if the content is what was supposed to be.
Yeah. So it looks like though the caveat here is that the file has to exist.
Yes, but it's still saying that the file does not have the right content.
Yeah. Oh, I see right here. Mark degraded.
Yeah, but now if you VI your file and put that in there, it's gonna work.
Let's see. Is Jaafar right? We'll see.
Jaafar right?
We'll figure this out right here. Is Jaafar right?
Is he always right?
He's no Andrew. Come on.
Yeah.
He's no Andrew.
I'm sometimes right, sometimes not. But I think I have an intuition that it's gonna work.
So this is foo.conf, right? What do I put in here?
Yeah, like just copy paste the. No. You need to put the content which was OpenShift is the best platform. Blah blah blah.
Oh, okay. I see what you're saying. This guy right here.
Yeah, exactly. Yeah.
With the new line.
Yes. With the new line.
All right, let's see here. Validated on disk. All right, chug along, chug along. Oh, it did a reboot. Yep, you're right.
So what it says, it's at least you cannot trick it into putting whatever dummy file.
Yeah.
Where you needed a specific configuration.
Yeah, so if I go in and write the file, yeah, like you say, you can't trick it, to have a certain configuration. It'll be a mismatch, and it'll just mark it as degraded.
Yep. So what we need to check if this is intended behavior.
Yeah.
To let you know that one of your nodes is not compliant, or if this should be enforced.
So actually, when it comes back, I actually want to do it again, and I want to see if the alert manager goes off on the web UI, because I'm just curious. Yeah, see here, it's actually doing a rolling update.
And now you should get the new content, which is on Andrew is always right, and Jaafar,
always,
and Jaafar sometimes right.
So Jaafar is sometimes right. Yeah, exactly. All right, so now it's back. And then so ls etc foo.
Yeah, cat. Just cat.
Foo. All right, so we have all of them. Yeah, we etc foo and then foo.conf. Okay, that's Kubernetes platform, and then other. Andrew's always right.
Yeah.
There we go. So we got it back. So now that we got it back, I actually want to break it again. Probably the last thing we'll do here. I want to see.
But can you check? Can you show the machine config that you put in there?
The OC get machine config for this guy here.
Yep. So it says.
It says base 64.
Yep. So we need to check if there's like an option to.
Oh, like in the specification, like in the spec, that we can say.
Yeah, create it if it's not there or something like that. Or...
So let's see here. Oh wait, I need to change the. So let's do this again. Andrew, oops. Jaafar is sometimes right. Okay, let's change that. I was trying to trigger the error, but you need to actually OC edit. And then let's put this in the other one here. So put this in the Jaafar one. This is the Jaafar and the Andrew one. Yeah, so OC get this logs. See if this helps. Or is it even this node? OC get pool. I don't know which one. Let's just look at this one here. Give it a little bit of time. Ba-da-ba. While that's going, give me cat Twitch cluster install. Open link. Come on. Here we go. And then cube admin password. It rebooted that time. Okay. Where am I here? Alerts. Which one did I remove the config from?
It was 215 something.
Services. No, I want. Where's the monitoring?
Okay.
I just want to see if there's an alert.
Alert. Okay.
Yeah, about it.
Yeah.
Target down. So you got that. I know that works because I set that up in another cluster. OC get pods.
And which
one? This guy.
So which alert are you looking for?
Well, I want to see if that the because remember when I removed the configuration, I wanted to see if that gives that degraded like if I go MCP updated machine count 1 ready updated. So I just wonder like if I remove that file, if I get chroot host, if I get an alert rm etc foo.conf.
Oh, you mean the fact that the operator, the daemon didn't validate the configuration?
Yeah. So that error that we get, I wonder if that's something that
shows up somewhere.
Yeah.
Mm-hmm.
Okay, this is what I wanted. Okay. Logs. It's the same. Okay, maybe because it just went down. See, now that I want it to error out, it's not going to error out.
Of course.
Of course, right? When I wanted to.
Of course. I believe this is the same problem you had the other day, right?
Yeah. Damon said rollout stuck. Okay, well, that's. Always sometimes. Yes, always sometimes.
Always sometimes.
So did it reboot the node or?
Well, it's doing something. It's working now when we don't want it to work, but make another edit. Make this 4 4. Okay. All right. That should say 4. It does. Let's see logs. So now we wait.
So what did you do?
I just made a change so that way it has to
reconcile.
Yeah.
Forced reconciliation.
Forced reconciliation, yeah. I just hope I'm watching the right pod. Debug. Yeah, so there's only one file there. Okay. So get pods, get pod 215.215, get OC logs of that guy, and I want the machine config daemon. Come on, daemon. You can do it. Watch it fix it, right? Watch it,
Right.
watch it work right now.
By you running this command.
Target down, target down. Yeah, it's rebooting it.
Huh.
I wonder what series of events led me for it to not work at the first time. Because look, now it's rebooting.
Right.
It's just the demo effect.
The demo effect. I love it.
So
Once you check that box, it works.
Never happen again.
it's
Every other day.
yeah, that's right. Every other day. Yeah. What? Yeah. So now when I go and show this to someone else, then it won't work. It'll revert back.
You just have to go through it the first time.
Yeah, it added the file now.
And what's the content?
Oops. CD at foo. Andrew's always right. And this one is, I think Jaafar is sometimes right.
Okay. So it seems to work.
It seems to it seems to work, yes. It seems to work how we hoped it would.
Exactly.
It's almost like it was built like this.
Yes, it almost feels like it was built like this.
Works as designed.
Works as designed, except when we do it the first time.
Great.
Except when we're demoing it, then the demo gods say no. We're gonna make you look dumb.
Yes. We have to make you look human in front of everybody.
We have to make you look as human as possible.
Yeah, at least they know it's live. It's not.
Well, at least we're doing it on a non-production cluster, right? This is where you want to mess around.
Yeah, exactly.
To try to figure out how it works. That way it's not a surprise when it happens in production. Because it'll inevitably happen to you in production. So
I'm actually going to kick off an update to 4.5.3.
Yeah, there you why not?
Just cause.
Just because, yeah.
Because Christian said so.
It's in the fast channel, right? So if I do OC edit, it's clever. Doesn't have receipt. I have to do the whole thing. 4, 5. By the way, this is how you do it. 4.5.2. Oops. We are in stable. 4.5. Yeah. So stable. We want fast. Not fast, right? Is it fast? The fast channel.
Fast or candidate?
For what? What did you want?
Let's go to Rob Zeminski's amazing candidate. Is what I want. Yeah.
Yeah, candidate.
I did fast. I want did 8 because Andrew's watching. OC ADM upgrade.
So I also see it in the fast channel.
You see it on the fast channel as well?
Yep.
Cool.
That's how you upgrade. It's 4.5. Oh yeah, it's in the.
All right.
It's there. This is how fast things move. It wasn't there like literally like when I looked at it like the start of the stream.
Hour ago, 2 hours.
Yeah, like an hour ago, it wasn't there. So
that's why it's called the fast channel.
That's why it's called the fast channel. It moves pretty fast.
It does move fast. It's more than us working here at Red Hat. Yay!
Yeah. Well, yeah, exactly. The world doesn't stop because we stream. So you need to be at least at a 4.410 to go to the fast 4.5. Cool. So yeah, I don't have anything else to show. I don't know
That's
if anyone
awesome.
has any questions. It was fun learning together.
This was fun learning together. Thank you so much for joining us.
Yeah,
Seriously,
great.
like this has been great.
Yeah.
So yeah, without further ado, this is the last stream for today, I believe. Tomorrow, we're having some more GitOps talk using Tecton for CI and Argo for CD, which is cool.
That's right. That's gonna be cool.
Yeah, Christian, you set that up. I appreciate that.
Yeah, no
and
worries.
Then
have some cool guys on.
Yeah, like gonna have some new people on the show. So
Yeah. No, they did some good stuff with the GitOps and Tecton. So
yeah,
be sure to watch that.
Ryan Cook and Mario Vasquez.
Yep.
Yeah, I said that right. Cool. I'm glad I can say things right still. Yeah,
that's right.
Yeah, that'll be at 1400 UTC, 10 a.m. Eastern, and that'll run till noon. So yeah, cool. Get your GitOps on tomorrow with us here, folks.
All right.
For now, we'll holler at you later.
All right. Thanks, everyone. Have a good one.
All. Have a good day. Bye-bye.